Hello, this talk is for IEEE WASPAA 2021. Here we would like to introduce a dataset we recently released called MeshRIR. I'm Shoichi Koyama from the University of Tokyo. A large number of datasets of acoustic impulse responses, or IRs, are currently available, such as RWCP SSD, AIR dataset, and so on. But most of them are designed mainly for evaluating speech enhancement, source localization, and also oralization. On the other hand, sound field analysis and synthesis methods have been extensively investigated in recent years, which are aimed at estimating or controlling a sound field inside the spatial region. Since intervals between measurement points should be sufficiently small for evaluating these methods, current IR datasets are not applicable. So the evaluation of sound field analysis and synthesis is limited to numerical simulation in many cases. We recently released a new IR dataset called MeshRIR, which is freely available at this link. MeshRIR dataset has features listed here. First, measurement points are set at finely meshed grid points inside the spatial region. The intervals are 0.05 meter. So this dataset is suitable for evaluating sound field analysis and synthesis methods. Currently, two subdatasets are included. One is IRs from single source to 3D cuboid, and the others is IRs from an array of 32 sources to 2D square. And this movie is a pressure field in a square region visualized by using this dataset. Several example codes for sound field analysis and synthesis methods are also provided. Two subdatasets are called S1M3969 and S32M441, respectively. The first one is the IRs from a single source to a 3D cuboidal region. So this subdataset is designed for evaluating sound field analysis and estimation methods. The configuration of the source and microphones is shown in this top right figure. The measurement region is 1 meter by 1 meter by 0.4 meter. The intervals of measurement points are 0.05 meter. So the number of measurement points is 3,969. The reverberation time is 0.38 seconds. The second one is IRs from an array of 32 sources to a 2D square region. This subdataset is designed for evaluating sound field synthesis and control methods. The configuration of the sources and microphones is shown here. The measurement region is 1 meter by 1 meter, and the intervals of the measurement points are again 0.05 meter. So the number of measurement points is 441. The reverberation time is 0.19 seconds. We placed several sound absorption panels when measuring IRs for this subdataset. So the reverberation time is a little bit shorter than that of the first subdataset. The IRs of this dataset are measured by the Cartesian robot equipped with an omnidirectional microphone, shown below. So the IR at each measurement point is obtained one by one by moving the microphone position by using this system. The manufacturer and model number of microphone and loudspeaker are listed here. We used linear swept sign for the excitation signal of IR measurement. The detailed measurement conditions are summarized in this table. And the file format is NPY for NumPy Python and MAT for MATLAB. Since it took many hours to complete the whole measurement, we also tracked the room temperature. The average temperature is shown here, but its variation was within 1 degree Celsius. And all the additional data, like temperature and positions of sources and microphones, are provided as a JSON file. We also included several example codes for evaluating sound field analysis and synthesis methods. So these figures are sound field visualized by S1M3969. The left figure is the pressure distribution on the XY plane at z=0. As you can see, wave motion from a single source is visualized, including reverberation. The right figure is IRs with respect to the time along y-axis. So the direct sound followed by reflections passes through the y-axis like this. As an example, we show experimental results of sound field estimation using S1M3969. The pressure field inside the entire region is estimated from the signals of 18 microphones at these black dots. The top left is through pressure distribution. The middle one is the result of the kernel interpolation method proposed by the authors. The kernel function is derived for interpolating sound fields. The right figure is also the kernel interpolation, but the generally used Gaussian kernel is used for kernel function. The bottom figure is a time average error distribution, so highly accurate estimation is achieved by this kernel interpolation method. We also showed the results of sound field control by using S32M441. The details of this result can be found in this conference paper. We synthesized a plane wave field by using 32 loudspeakers. The top left is the desired pressure distribution. The middle and right figures are the pressure distributions synthesized by the weighted mode matching and pressure matching. The crosses indicate the positions of control points. And the bottom figures are time averaged square errors. The SDR, signal to distortion ratio, was 4.65 dB and 3.85 dB respectively. So this weighted mode matching was better than pressure matching in this case. Finally, I conclude this talk. We introduced MeshRIR dataset, which is a dataset of acoustic impulse responses at finely meshed grid points. Two subdatasets are currently included. One is IRs from a single source to a 3D cuboid. And the other is IRs from 32 sources to a 2D square. We believe that this dataset is suitable for evaluating sound field analysis and synthesis methods. We plan to further extend the dataset to other source and microphone configurations and room conditions. If you are interested, please visit this website. So, thank you for your attention.